Talk about quadratic functions today. Now, we've hit on it just a little bit, but I'm going to go through it as if this were the first time. Now, we do have an I can statement because we have already worked with quadratics. A quadratic is one of our parent functions. And it has a nice smooth U. Whether or not it opens up or down is not relevant. It is a nice, pretty smooth U. Okay, that's what the quadratic function looks like. That in particular function is called or that in particular graph is called a parabola. Okay, it's a nice smooth U. Okay, we have recognized it and used it tons in the vertex form, so you can recognize the quadratic function in vertex form. Now, what we will do, and we will focus on that today, we will recognize the different quadratic representations. Okay. Specifically, we'll recognize the general form of the equations. The equations are listed up here in our standards. Okay, we will identify the y-intercept of a quadratic function, and we will solve quadratic functions lots of different ways, but specifically today by taking square roots. Okay, now, the quadratic function in vertex form, we've already done this when we did our parent functions. Remember a quadratic has r squared up here, okay? This is in vertex form. Vertex form is right here. This is our second equation right there, where hk is our vertex, our axis of symmetry is x equals h. A is our vertical expansion or compression, and remember, in order to have an expansion, A has to be greater than 1. In order to have a compression, the A value has to be between 0 and 1, okay? A negative does not count. A negative just reflects it. It reflects over the x-axis, okay? So again, this is describing our transformations, okay? We've done that. This right here, this is one of our equations that's in vertex form. And what we're gonna do is we're just going to hit and review what we have already learned. First and foremost, we always say what family it is. This is a quadratic family. So this is the quadratic family. Okay, we are comparing it to its parent function. Okay, very first thing that we see is that 1/3, our A value. A is less than 1. So we have a vertical, and since it's less than 1, it's a compression. We have a vertical compression by a factor of 1/3. Okay, it's by a factor of 1/3. The very next thing we see is that +3, and if we remember, it's x minus h. Okay, in order to see a minus, this would have to be x minus a -3. So h is a -3. So that means we have a horizontal shift. And since it's a -3, our shift is left 3 units. Okay. The very next thing that we see, we've already just said that it was a quadratic family, is our -2. That's our k value. Our k value is our vertical shift. Our vertical shift is exactly how it appears. We have a vertical shift. That's a -2. So since it's negative, it's down 2 units. Because we had any shift at all, our vertex changed. So we have to mention that. I'm writing the wrong word. So we do have a vertex change. The vertex changed from our parent function, which was at 0, 0, to our new vertex, which is our h value, a -3, and k value, which is a -2. So my vertex did change from 0, 0 to -3, -2. Now, one thing that we need to remember, the very last thing that we ever discuss when we are talking about our transformations is our axis of symmetry. But our axis of symmetry only exists on two of our families that we've studied. That is our quadratic family right here, so we're going to have to mention it, and our absolute value. So we have mentioned our vertex change. Because this is a quadratic, we do have an axis of symmetry that changed. So our axis of symmetry, and it changed from our parent function, which was x equals 0, because that is a vertical line. So it changed from x equals 0 to x equals my h value of my vertex. H value is a -3. And like I said, we've done this. This is in vertex form. We love vertex form. We know right where to start. We can use our axis of symmetry, easy peasy. Okay? Now, these are quadratic functions. These are in our different representations, okay? Our equivalent equations. They're all quadratics. This one here is our vertex. We can see our vertex. This is vertex form. Vertex form is also called standard form. Standard form. So vertex form is often referred to as standard form, where we have our h and k. Our h is 1, our k is +4. It tells us our vertex, okay? Now, after standard form, I have right here. Notice we have two things multiplied together. If I FOILed this out, I would have x times x, which is x squared. That's how I get my quadratic. That's how I know it's my quadratic. This right here, this in particular form, is called the intercept form. Intercept form. Now, specifically, it's our x-intercepts. And our x-intercepts are where it crosses the x-axis. So just by looking at this right here, okay, here's my coordinate grid, XY grid. I'm going to cross my x-axis at a +1. So I'm going to cross it right here. And then at a -3, because remember these are opposite of what they appear, so it'd be 1, 2, 3. So it's going to cross here. Now, this is a 2. I'm not exactly certain where the vertex is at this point. We'll hit on that later. But my quadratic, my parabola is going to go through like that. It's going to cross at a -3 and a +1. And we're going to talk about this form right here in just a moment. I will show you with our intercept form, talking specifically about our x-intercepts. When it's an intercept form, okay, we are specifically talking about our x-intercepts, where it's going to cross that x-axis. Last but not least, we have this form right here. This is called general form. Let me put it in red. Okay, this is called general form, and it's also referred to as standard form. The beautiful thing about standard form is it tells you where it crosses the y-axis, okay? It's going to tell you your y-intercept. Your y-intercept, and I can't spell intercept apparently, your y-intercept is where it crosses the y-axis, and it is this lone number all by itself. So there's lots of things that we can determine from just the form that the quadratic is in. This right here, we can determine the vertex and the axis of symmetry just by looking at it. Okay, we can also tell if it's an expansion or compression, and with the A value, this value out here, it's going to be an expansion. A's larger than 1 right here, so of course it's going to be a vertical expansion. This is an intercept form. I know, and I will learn more about this, but right now I know from intercept form it's going to cross my x-axis at a +1 and a -3. I'm not really sure yet at this point where my vertex is, but we'll hit that in one of our lessons. Last but not least, we have our general form, not standard form, and I'm not even sure why I said standard form. Standard form is up here, so please, understand, I didn't mean to write standard form. I meant to write expanded form. Expanded form means that I actually multiplied that out and distributed it in combined like terms. So general form is expanded form. So please forgive me for me misspeaking earlier. So recognizing the different quadratic representations gives us a lot of information about what the graph would look like. This right here, here's some classifications. With this right here, we're going to look at 1 through 6, and we have different ones. And what I like about these, okay, is first of all, this is expanded. Nothing has to be multiplied together. So this right here, we're going to use both terms. We're going to say this is general form, G-E-N-E, can't spell again, general form or expanded form, G-E-N-E-R-A-L, general form, and this is also expanded form. In my general form, in my expanded form, I have my y-intercept. My y-intercept will be 0, -17. That's where it's going to cross the y-axis at 0, -17. So on the grid somewhere, all the way down here at 0, -17, it's going to cross that y-axis, and since it opens down, it's going to cross that way. Okay, so that is where it's going to cross our y-axis. Number 2 is also, and I did this for a reason. Okay, both 1 and 2 are general form, expanded form. They're both multiplied out. We can identify the y-intercept here at 0, -17. Y-intercept here is 0, -5. That's the y-intercept if I'm identifying the y-intercepts. Right now, I'm just classifying the type of each, but I can be asked anything. Expanded and general form, both of these, general form, expanded form. Y-intercept here is 0, -17. Y-intercept here is 0, -5. Because this number right here is a -5. This number right here is a -17. So we know where it's going to cross the y-axis. Now, 3 and 4, both of them are what we're familiar with. This is our vertex form, which is also referred to as standard form. We are going to discuss both forms. Don't put one or the other. Let me know you know it's both, okay? Now, again, with our vertex form, we can talk about, hey, our vertex is a +3, +3. We can talk about our vertical expansion. We can talk about reflections, things like this. But in here, we're going to keep it just simple. Here, we talked about the y-intercept. So when it's in vertex form, we're going to talk about the vertex. The vertex on here, right here, H is a +3, K is a +3, okay? This is my vertex on number 3. My vertex on number 4, okay, that my H right here, in order to see a +2, it has to be a -2, and K is exactly how it appears, -2, -2. Now, number 5 and 6, again, we've done general form, expanded form, we've done standard form, vertex form. This one right here, number 5 is our intercept form, okay? Our intercept form, specifically our x-intercepts. It's our solutions, so to speak. And what we can do in both of those, 6 and 7, we can talk about our x-intercepts. X-intercepts are also solutions, okay? They're solving the equation. So my x-intercepts, we can write them like this. We have a 0, this would be a -3, and we have 0, +7, because H here would be a 7. These are known as supposedly P and Q's. Now, with that said, I can say they're x-intercepts. I can also say they're solutions to the equations. When we're talking about solutions, we only list in solution set form least -3 to greatest, which is +7. So x-intercepts are solutions. They're also called zeros. Okay, x-intercepts are solutions, which are also called zeros. And that's what we can find out from our intercept form. Okay, this one right here, okay, our x-intercept, I'll write it in the green. Our x-intercept right here is 0, 1 and 0, -5. So we have our x-intercepts here. X-intercepts are also called zeros or solutions. If we're talking about zeros or solutions, we list them in solution set form, least -5 to greatest of +1. So that's what we have in those. And you're going to be asked to classify quadratic functions. You may be asked, what's the vertex of this one? What's the y-intercept of that one? Or it may be classify each quadratic function. If it's in expanded form, then tell me the y-intercept. If it's in intercept form, tell me my solutions. I might say that. If it's in vertex form, please state the vertex. So these are all of these things can be asked. Okay. Next thing we're going to talk about is solving quadratics by taking square roots. We hit a little bit on this yesterday. Now, I'm not sure how I'm going to do this. I think I'm going to come down here first, because first and foremost, each time, every time, all the time I'm solving, my goal is to isolate the variable. So I'm going to do my order of operations backwards. Every time I'm solving, I'm going to do order of operations backwards. So I look up here, is there anything added or subtracted to my variable? Well, there is. That's this -10. So in order to get rid of the -10, I need an additive inverse. The additive inverse of a -10 is a +10. So I add 10. What I do to one side, I do to the other side. So I'm going to add 10 over here. Plus 10 there. Handy dandy line. Now I have a -7m squared equals -591, and a +10 is a -491. Okay? We're going to divide both sides by 7. That's not -491, -591. What am I doing? 591. Divide by -7. Negative over a negative makes for a positive. So I get m squared is a -591 divided by a -7. We are going to utilize our calculators a lot. Now I know, and I can do this without a calculator, but we are going to, actually we're going to find this. There. It's not letting me pull it up. Let me see what I come at. But we're going to utilize the tools that we have. Now, currently I've got our TI 83 plus, or 84 plus CE, okay, our graphing calculator. And I have a -591 divided by a -7. Now, first of all, I know a negative divided by a negative is a positive, but if I don't, I can still use those. You can use the division bar, you could use the fraction bar, it doesn't really matter. I know I'm going to deal with the positive, so I am not typing in my negative. I am simply just going to type in 581, and I'm going to divide it by 7. I should get 83. Now again, it is a -581, and let me show you that. -581 over a -7, I'm still going to get a +83. So, just showing you how to utilize your calculator. So I have an 83. So here I go. I'm going to hit back. Maybe. There we go. I'm going to come back over here. I get m squared equals 83. Now here's the kicker. I don't want m squared. I need my value of m. Okay? So in order to just get m, I have to take the square root of both sides. The square root of m squared and the square root of 83. Now, oh my goodness, let me do that. I've got the square root of m squared is m equals. Now, but a square root, let's stop and think about this. I'm going to leave this for a minute. I have the square root of 4. Most of you guys are going to tell me the square root of 4 is 2. And that is correct. 2 times 2 is 4. But isn't a negative 2 times a negative 2 also a positive 4? So technically the square root of 4, an even root, can be positive or negative, and we have to keep that in mind. Now, I am going to hit back at my calculator, and for whatever reason, that's not one. There we go. Okay, so I need the square root of 83. So I'm going to come over here, and actually, let's look at the square root of 4 first, okay? We're going to talk about how to, whoops, I better erase that. We're going to talk about how to work our calculator. So the square root of 4 is 2. We know that, but it's also a negative 2. But I'm wanting to show you this. If I take my square root of 4, I hit enter, my calculator will only spit back out my principal square root, which is the positive, okay? So even though my calculator gives me a positive 2, I have to have the mathematical knowledge to know it is also a negative 2. So now I need the square root of 83. I get second square root of 83, and I hit enter. 9.1. Okay. When I get something, the square root of 83, it's 9 point something. It's between 9 and 10, because 9 squared is 81, 10 squared is going to be 100, so that's not going to be a nice, pretty number. The kicker is how does it simplify? Now, I can simplify without a square, without a calculator. I am not sure if I've got my other one up here. I might. Let's see if I do. No, I do not have it up there. Okay. So, let's see if I can do this. So here's what I want to show you. Now, on our, let's see, can you see this? Our TI-84, or our TI-83, not 83, TI-30XS. On this, we have math print. And the beautiful thing about it, and I do like it, let me go turn on the line just for a minute so you can see this, okay? I need to do the square root of 83. So in order to do the square root of 83, I'm going to do the same thing. I'm going to hit second. I'm going to hit my square root, and I've got 83. So I've got this, actually I put 86, let's fix that, 83. So I've got 83, I'm going to hit enter. I've got this set on math print, and what this says is that this radical will not simplify. It's simply the square root of 83. But you don't have one of these. You don't have these to determine if that's a square root, if it simplifies or not. For example, the square root of 12 is going to simplify to 2 square roots of 3, just like that. But our fancy little calculator doesn't do that. We have these little TI-30XS's, and they're great. But let me show you how to get around that, how to work that on our 84 plus CEs. Now, what we're going to do is I'm going to do 12 first. Okay, and we just saw the square root of 12 is 2 square roots of 3. So I'm going to utilize my TI-84 to do that. Let's say I don't know that the square root of 12 is 2 square roots of 3. So I'm going to hit my y equals function. I'm going to clear this. I'm taking the square root. Anytime I'm taking the square root, I'm going to divide by x squared with my calculator. So I'm going to take 12, and I'm going to divide by x. X is next to your alpha button, and then I'm going to square it. I've got 12 divided by x squared because I want to know what the radical is simplified. Well, I hit enter. Fine. Oh, I didn't do anything. We don't care. This isn't what we want. We want to look at the table. So we come back up here. We hit our shift key, our second function, and we're going to hit our graph button, which actually is our table, and our table comes up. On our left is our x values, on our right is our y values. What we're looking for, okay? What we're looking for is integers. I've got y value at a positive 3, x value is a negative 2. okay? And then, and let's see if this will let me go. Yeah, it will. Then I have a positive 2 and 3. I want integers. Now, I've also got 1 and 12. But what this is, my x values are, when I find my integer, there's an integer, and there's an integer. This tells me what my radical is going to simplify to be, okay? Because I divided by x squared. My x is outside the radical, so this would be a negative 2 outside the radical. My y value is a 3, is what's inside the radical. So I've got negative 2 square roots of 3, and then I have a positive 2 square roots of 3, and that equals, that is the square root of 12 simplified. It is both roots. It is not just the principal square root. So to simplify the square root of 12, it would be a negative 2 square roots of 3 and a positive 2 square roots of 3. And you're going, okay, well, we had the square root of 83. Well, yeah, but I wanted to show you how to read this. So now we're going to do the square root of 83. When we did it, when we actually took the square root, it was 9.1 something, but they didn't tell us to round or anything. So I need to find the square root of 83. So I hit 83. I'm dividing, again, I'm taking the square root. That's what we're going to be doing. So you're going to divide by x squared. And I want to look at the table, second graph, or my table function, maybe. There we go. And now I've got different values. Again, I'm looking for integers. Now, if I got 2.305, let me go that way. I go from 2.3 to 1.6, and I'm just getting smaller. And that's not going to work. So I don't have any integers there. So I come down here. I got an integer right there. I got a negative 1. Oops, let me get that out. Let's see if I can find those. So I'm coming down. I got an integer right there. Oh, looky there. I got an integer right there too. So, and I need to go ahead and look at my positive 2. Let me go ahead and look at my positive 3s. Let's see what's going on there. Oh, and again, okay, right here, I got 1 and 83, 2, 29.5 point. Again, I'm getting smaller, but I'm not getting integers. After 2 is 1. That's not going to work. So I have them. I've got my negative 1 and my 83. And I got a 1 and 83. Those are my answers. So a negative 1, now technically, the negative 1 is outside the radical. Inside the radical is 83. But it's not proper form to write a negative 1. So we simply write negative square root of 83. And then, of course, we have our positive 1 square root of 83. But again, it's not proper to put that 1 out there. So I have a negative square root of 83 and a positive square root of 83. And we write our answer in least to greatest in solution set form. Negative square root of 83 and a positive square root of 83. So when I go back and I'm doing this, okay, I've got all my work right here. And from there, what we can do, and what I would like to see in your work, is we know, we've looked at our calculator, I've got a positive and a negative square root of 83. So that's all in my work. But I've got to type my answer, I've got to write my answer in proper form. So I have my braces, least negative square root of 83 to greatest positive square root of 83. And I'm finished with that one. Okay, so that's not too terribly bad. Now, if I come over here, okay, again, I'm not sure how it is. It doesn't really matter. I'm going to subtract 5 from both sides because I want to isolate x. I get 8x squared equals 792. Okay, I'm going to divide by 8. And so I get x squared equals 792 over 8. I'll be honest, I don't know what's 7 off the top of my head. So we're going to pull out our handy dandy calculator. Maybe, if I can pull it out. Okay. I'm going to quit. That's why I want to quit again. Okay. let me erase this. I have 792, and it's going to be divided by 8. We're just going to see if it turns out nice and pretty. 790, well, I've got to put that in there. 792 divided by 8 gives me 99, okay? So, in my work, maybe, there we go, I've got x squared equals 99. So here I've got it. X squared equals 99. But I don't want x squared, I want x. So I take the square root, I get x equals, I'm telling you right now, I know what this is going to simplify. I've got a plus or a minus. I know it's going to be 3 square roots of 11. It's going to be a positive 3 square roots of 11 and a negative 3 square roots of 11. I'm going to go ahead and write my answer, negative 3 square roots of 11 and a positive 3 square roots of 11. Shut that. And now I'm going to show you, now I know what it is, I'm going to show you what it looks like on our calculators. I have to take the square root of 99, so I'm going to come back to my y equals, I've got 83, I'm just going to retype over it, 99 divided by x squared. I need my table, second graph or second table, and there's my table. I'm looking for integers in my y column. Okay, oh, well, looky there. I got a negative 3 square roots of 11, because then I go from 11 to 6, and that's only going to get smaller, and I can go back, and then I've got a positive 3 square roots of 11. And remember, my x value is outside the radical, my y value is inside the radical. My x value is outside the radical, my y value is inside the radical. Well, I'm not sure what happened there. Negative 3 square roots of 11 and a positive 3 square roots of 11, and I put it in my solution set form. So that's how I can read those, okay? Let's go back here. Let's go, and we're working our way backwards. Okay, we're gonna do this one. Again, we're gonna subtract 2 from both sides. 7x squared equals 700. Divide both sides by 7. X squared equals 100. Take the square root. X equals, I know the square root of 100 is 10. I know that. And I get plus or minus 10. Okay? So to write my answer, negative 10, positive 10, and I close it. Okay? So we can get nice, pretty answers like a negative 10 and positive 10. We can get a negative square root of 83, positive square root of 83, and then we can have radicals in our answers. Not a big deal. Okay, let's look and see what this one gives me. Excuse me. I'm going to isolate x squared, add 8 to both sides. 16x squared equals 36. 28 and 8 is 36. Divide by 16. Okay. X squared equals, now again, I'm going to do 36 over 16. I know what this is going to be, okay? If you don't, that's okay. You're going to take the square root of both sides. I'm telling you right now, x is going to be plus or minus. If I put this in my calculator, it's going to spit out 3 halves. But the square root of 36 is 6, the square root of 16 is 4, and this simplifies to 3 halves. So I would get a plus or minus 3 halves. And I can do this in my head, and like I said, if you punch this in your calculator, you're going to get out 3 halves. It's going to spit it back out. So I have a negative 3 halves and a positive 3 halves. We're going to put that in our calculator. We're going to do 36 over 16 square root, and we're going to put our answer in solution set form. Okay, let's pull up our, okay, let's go back here, get out of here, and we want the square root, okay, second square root of 36 over 16, 36 over 16. I told you it would spit out a positive 3 halves because it's only going to give us our principal square root. So that is it for today. Your assignment is posted on Google Classroom.